Okay, next problem. So they are 230 volt. Resistor R1 is 12 ohm. And resistor R2 is 20 ohm. And resistor R3 is 15 ohm. R2 20 ohm and R3 15 ohms are connected in series. Then they are connected in parallel with R1 12 ohm. So this is the connection. R1 is 12 ohm, R2 is 20 ohm, R3 is 15 ohm. R2 20 ohm and R3 15 ohm are connected in series. Then they are connected in parallel with R1 12 ohm. To the supply voltage is 230 volt. Voltage we have to calculate. So in this case, we need to find out the total equivalent resistance. R equivalent need to be calculated. The current in each branch. The current flowing into the R1 is a I1. Current flowing into the R2 and R3 combination is a I23. Have to be calculated. I1 need to be calculated. I23 need to be calculated. Because of the current in each one, each branch need to be calculated. Then we also need to calculate the total supply current I total. I total need to be calculated. Power dissipated by the each component. So power dissipated in the R1 is a P1. Power dissipated in the R2 is a P2. Power dissipated in the R3 is a P3. P1 to calculate, P2 to be calculated, P3 to be calculated. Both things have to be calculated, and also that we need to calculate that to the power. Both things has to be calculated. So this circuit given R2 20 ohm and R3 15 ohms, they are connected in series. The series combination of the R2 and R3s are connected in parallel with the R1 12 ohm. This is the connection. We have to calculate the branch currents. R1 branch current I1 need to be calculated, and also R2 and R3 series combination, their current is I23 need to be calculated. Total current is IT. IT need to be calculated. Power dissipated in R1 is a P1, power dissipated in R2 is P2, power dissipated in R3 is P3. P1, P2, P3 to be calculated as well as to the power PT to be calculated. All these are questions for this problem. So firstly, we have to calculate. R2 and R3s are connected in series. Therefore, we can write down the equation. R23 is equal to R2 plus R3. So the R2 is at 20, R3 is at 15. You got the 35 ohm. R23 series combination, the resistance is 35 ohm. This R23 series combination is connected in parallel with the R1. Therefore, we can write down the equation 1 by RT equal to 1 by R1 plus 1 by R23. So therefore, this equation is RT equal to 1 divided by 1 by R1 plus 1 divided by 1 by R23. So this is the way we calculate it. So the R total to be calculated equal to 1 divided by 1 by R1 is 1 by 12. 1 by R23 is 1 by 35. So 1 divided by 1 by 12 plus 1 by 35. So this is 1 divided by 1 by 12. 1 divided by 12 is equal to 0.0833. Also, 1 divided by 35. 1 divided by 35 is, we got the 0.0285. So the 1 divided by 0.0833 plus 0.0285. 0.0833 plus 0.0285. So we got 0.1118. So 1 divided by 0.1118. So that will be 8.94 ohm. So this is total resistance. Total resistance is 8.94 ohm. Then we calculate the total current IT. So and also that we can calculate each resistor. So in this case, the resistor R1 current I1. Voltage is at 230 volt. Resistance is 12 ohm. So 230 volt is across the resistor 12 ohm. So the voltage by resistance we can calculate the I1. I1 equal to V divided by R1. The voltage is 230, resistance is 12. 230 divided by 12. So we got 230 divided by 12. So you got there 19.17 ampere. I1 is 19.17 ampere. And similarly, you can calculate the I23. Because of the R2 and R3 are connected in series, they got the same current, I23. So the voltage draw across the both R2 and R3 is at 230 volt, and so the current I23 can be calculated voltage divided by R23. Voltage in 230, R23 combination is we can calculate. That will be the 35 ohm. 230 divided by 35. 230 divided by 35. So you got 6.57 ampere. So the I23 is 6.57 ampere. So this is the same as a R2 current is 6.57 ampere, as well as R3 current is 6.57 ampere, because they are connected in series. R1 current is 19.17 ampere. Then we also need to calculate supply current I total. I total is we can be calculated two way. I1 plus I23. You know the I1, you know the I23, we can add together. 19.17 I1 current and 6.57 is a I23 current. So 19.17, 6.57 plus 19.17. So that will be 25.72 ampere. So this is to the current ID. Or we can also calculate. We know the voltage, we know the total resistance. So we also calculate I total equal to V total divided by R total. V total is 230 volt. Total resistance R total is 8.94. Also the same calculation. So 230 divided by 8.94. This is also 25.72. So there are two ways to calculate. Because of that, we already know the I1 and I23. So by adding the I1 and I23, ID can be calculated. This is the first method. Second method is we know the voltage is at 230 volt. Total resistance we also know already know that 8.94. So the voltage total divided by total resistance 230 by 8.94. We got there 25.72. So both are the correct answers. This is the way we calculate. Then we calculate the power dissipated in each branch. We know the current, we know the resistance, then we can calculate the power. So the P1 can be calculated I1 square multiply R1. So I1 current is 19.17 square, and R1 value is at 12. 19.17 square multiply 12. 19.17 square multiplied 12. So you got 44081. P1 is 44081. Also, we calculate power P2. Power P2 is a I23 multiply R2. So I23 square multiply R2 is I23 is 6.57 square. R2 is at 20. 6.57 square multiply 20. 6.57 square multiply 20. So you got the 863 by 3 watt. We calculate the P3. I23 square multiply R3. So I23 square multiply R3 is 6.57 square multiply 15. 6.57 square multiply 15. So you got 647.471. 647.471. So this is the way we calculate the power in the R1, R2 and R3. Then we can calculate to the power P total. P total equal to P1 plus P2 plus P3. So that we add all power together. So the P1 is 4408, P2 is 863.3, P3 is 647.47. Then we calculate the total power. That will be 5915.61. 5915.61. So this is the way we calculate it. So in this case, the first these are we calculate the R2 and R3 connected in series. Then R total is 1 by R1 plus 1 by R23. Then we calculate the R total. If you know the R total, so the current can be calculated. So voltage divided by R total, so this is IT. IT can be calculated. And I1 can be calculated, voltage 220. So the resistance 12 ohms, so the V by R1, so you got a 19.97. I23 can be also be calculated, voltage 220, voltage 230, R2, R3 combination the 35, then you calculate 6.57. I total IT plus, I total equal to I1 plus I23, or VD by RD. Then the current flow into the resistors are R1 current is I1, so the I1 square multiplied by R1, you got the P1. And I23 is a flow to the both are R2 and R3, so the I23 square R2 is a power P2, I23 square R3 is a power P3. The total power equal to P1 plus P2 plus P3, we got the total power. And similarly, we also calculate the total power as well. P total is you know the voltage total and the current total. Voltage total multiplied by current total, we can also calculate the total power. So in this case, the current total is voltage total is 230, current total is 25.72. So the 230 multiplied 25.72, we can also calculate. 230 multiply 25.72. This is also 591.5.6. So there are two methods. We add all power together, or you know the total voltage and total current. So multiply total voltage and total current, we can calculate the total power.